My name is Jaroslaw Ulczok. I am working for Thales, Thales CPL, because Thales is a big company. And yeah, today I'd like to say something about the HSE and how to use it for the data protection in motion. Yeah, whenever we talk about the data, it's a good point to start discussing three states of data. Of course, data can exist in three states. I'm pretty sure you are familiar with data at rest, data in motion or transit, and data in use. And when we, again, start thinking about the data protection, it's worth to think about in what state does the data stay the longest? Which state is the most difficult to protect? And third, in which state is your data most likely to be stolen? The answer, this is a good start point to use your customer to discuss in general your data protection strategy. The answer depends on who we are talking to. And typical answer for the first question is, of course, at rest, because we store data for a long time, and comparing to other states, definitely this is the longest. Second answer, in use. Yeah, we can't play with encrypted data in Word document, Excel, or email, for example, right? And the third answer is, yeah, at rest, in use, and in motion. The answer depends on who we are talking to. And yeah, typical answer of mere user is data at rest, because it stays in that state the longest. Okay, but if we talk, for example, to the security service or army related companies, they say in motion. I asked one of the guy, why is this? And he replied to me, hey, when my data leaves my perimeter, my on-prem area, I can't do anything. I can't do more anything, right? Okay, that's the argument. Okay, just I leave you with these answers here, and let's move on. Data protection good practices, among many good advices, says that of course, the couple keys on data, protect what makes sense, manage the keys, manage the access to the protected data, to the keys, etc., etc. One of the argument is protect the proper layer. I'm the engineer, and my experience says this point should say protect at possible layer, because in most cases we enter the customer environment and the solution is in place, and we have to apply the encryption. Sometimes it's really hard to apply encryption in ready use solutions. So, as I said, protect the possible or proper layer. In most cases, it appears that network is the proper, so-called proper layer. Let me disable my camera just to save some bandwidth. And yeah, let's continue. Okay, what are the common network threats and concerns? Of course, obvious is eavesdropping, fiber tapping, or the most recent danger coming from post-quantum cryptography, or the fact that soon we will have a working quantum computer, is the approach we call harvest and decrypt, or store and decrypt later. Record now, decrypt later, right? That's really a concern for some of customers. Besides this, if we talk about encryption on the network layer, customers expect no performance degradation. Yes, if you apply encryption, they would like to conserve the bandwidth, no more jitters, no more no increased latency, etc., etc. And the best, if the solution we can just put in the network without additional network configuration, without any hassle brought to the network configuration. yeah, future proof, as I said, customers are looking for the solution which does not have to be replaced every 5-10 years, because the standards are changing. Yeah, replacing the hardware is the most costly part of the budget. So they look for the solution which can just deploy and forget for many years. Yeah, quantum safe, this is another concern, customer concern. They would like to be quantum safe, so use, for example, quantum resistant algorithms already right now on the network transmissions. And of course, certified solution. Encryption is everywhere. You can find it in nearly any network device. However, customers would like to rely on the robust one, certified one, which really brings the security. Okay, the answer for all these concerns and questions from the Thales side is HSE. HSE stands for high-speed encryptors or encryption. We have a couple solutions starting from virtual. This is one of the recent solutions we delivered, because yeah, cloud adoption is quite high, and customers requested, hey, I would like to make an encryption towards my workloads located in the cloud. Of course, we have series of hardware encryptors, starting from CN 4000, which is, let's say, entry level or basic one, used to encrypt critical infrastructure, SCADA. This is the office solution. We have much bigger models like CN 7000, which is able to encrypt up to 10 gigabits per second. This is the encryption throughput. Please do not mix it with the interface speed. Network interface speed can be, of course, higher. We are talking about the useful throughput going through the device. And the biggest model, CN 9000, this is the most recent model. It is able to achieve 10 gigabits per second. And it also provides the lowest latency, below 2 microseconds. We are talking about microseconds, not milliseconds. Milliseconds are in the IP area. Those devices are really provides the very low, near to zero latency. Besides the let's say common platform we provide, recently we offer the pre-validated models on different form factors. You have seen a couple examples of this for in vehicle encryptors, for example, for military devices, for industrial controls as well. Excuse me. And what we do, we just pre-validate x86 platform on which we apply our HSE operating system. And hardware plus our operating system, and of course HSE application, provides the encryptor as is. 10 differentiator or 10 astounding features of HSE are, of course, we exist on the market because we follow the global certification, like FIX, common criteria, of course, NATO and others from Far Asia, for example. Because we do the encryption, we have to change encryption keys from time to time. That's why we have automated key management here. Thanks to the encryptors architecture, of course, this physical one, we use FPGA, full field programmable gateway arrays. We are able to change how the hardware behaves. For example, we can change which algorithms are accelerated in hardware, which are not. So this is the part of our crypto agile approach. Of course, yes, there are quantum safe. Quantum algorithms are already in our HSE. The current firmware contains the pre-standardized version. because our HSC talks to our HSC, there is no problem with compatibility. However, of course, recently, a couple of days ago, NIST published the post-quantum algorithm standard, and soon, hopefully by the end of Q4, we will have the new firmware for our HSC, which implements the standardized version of post-quantum algorithm. What else? Yeah, vendor agnostic and our bump in the wire approach. So if you have a network fragment to encrypt, that's no problem. Just cut the wire, put our encrypt on, configure them, and that's it. You can configure it and forget. Yeah, we can operate on network layer 2, so Ethernet. Layer 3, yes, we look into the IP packets. Even more, we can look into IP packets and verify which application is using that packet and encrypt it accordingly. As I said, low overhead, near zero latency. This is very important, especially when we talk to the network admins responsible for any media transmission. Yeah, so when latency really plays a role, and as I said, nearly no performance degrades. This latency and no jitter, it's really an outstanding feature of our HSC on the market. Comparing to other network encryption technology like MACsec or IPsec, for example. Okay, what are the typical use cases for data encryption in motions? Yeah, typical use case for our HSC is protect any traffic, any network running between your headquarters and remote offices, or your main data centers and backup data centers, or disaster recovery centers, or any place where you can't control the network traffic going out of your perimeter. Nowadays, it also means your traffic going to the cloud, to the cloud service providers. Yeah. By the way, ladies and gentlemen, you have a chat and Q&A to your disposal, so please use it. If any questions comes to you, use chat or Q&A to ask the questions. Yeah, now I'd like to switch to the demo. Let me. Of course, this is the recording demo, not the real one, because yeah, it's hard to have all this hardware next to me. First demo, I'd like to show you how what is the difference between how the HSC encrypts the traffic while comparing to IPsec, for example. Okay, so let's put it on the. Okay, this is the picture is maybe the schema is maybe a bit complicated, but we use this environment in IWS, two virtual systems, in order to test how do we perform in terms of network encryption. Okay, in packets encryption, comparing to IPsec. Okay, so we deployed the simple infrastructure where we can achieve 3 test scenarios. Okay, as a baseline, just to be able to compare how we perform versus IPsec, we run the test where no encryption of the network traffic. Then we will run the second scenario where we applied IPsec. For this purpose, we will use one of the common, well-known open source IPsec solution, which is strong SWAN. And then we will run exactly the same test against where we applied the HSC, the virtual one HSC deployed in IWS. Okay, let me run this. For the test purpose, we use exactly the same environment, 2 Ubuntu servers deployed in AWS, where we use tool iPerf to check what is the actual throughput. Okay, the iPerf, by the way, it's a very common tool used by many professionals to measure the actual bit rate. Okay, as I said, all the machines are of the same type, and CNX large, CN5 large. Oh yeah, and yeah, in order to test the actual throughput, we build this test tool. Test tool will start the IPperf test session based on the following parameters. You can see now the VPN is disabled. And we can set up the server against which we will run the test, the port, bit rate, which will be produced by the iPerf, MTU, and duration of the test. Okay, so when we run it, we speed up this a little bit. Okay. Okay, and the first step without the VPN, first test scenario, 10 seconds, and we get the results. We limit bitrate to 2 megabits on the test performance, and yeah, first output of iPerf, you see 2 gigabits per second, which is expected. Yeah, nothing influence our throughput. Okay, now we will start the VPN. Okay, so all the traffic from the client station where IPperf is installed to the OYA. You see the VPN is established. All the communication will go through the VPN. Okay, just to remind you, 2 gigabits without any encryption. Now we submit test once again for 10 seconds. And yeah, we will see what will be the result. And yeah, we achieved only, or yeah, at least 600 megabits per second, okay, with IPsec VPN, comparing to 2 gigabits per second or 2000 megabits per second when we use, when there is no encryption. Okay, let's switch now to the HSC. We use exactly the same environment, but it's located in different zone. This is in Paris. The previous test was in Stockholm. Doesn't matter, but the machines are exactly the same. This is exactly the same environment that deployed in different. The reason for this is that we have a limited elastic IPs in WS, so we had to move part of this test to another zone. However, as I said, the test parameters are exactly the same. So we have 2 megabits bit rate, port, MTU. Port, of course, doesn't matter, but MTU. This is because of the IWS. We required with a little bit smaller than the 100/500, but doesn't matter. For the test, we have exactly the same condition. Okay, so start the test. 10 seconds, and we will see how it looks like. And we achieve nearly or almost 2 gigabits, so 2 megabytes per second, 200 megabytes, 2000 megabytes per second. Why is this? If you know, IPsec encapsulates the traffic, IP traffic, which goes from one point to another, right? So this is a huge overhead. That's why we receive the performance degradation. For HSC, there is a different approach. We simply look into the IP packets, which has to be encrypted, and we only encrypt the datagram. We do not add any big overhead to the transmitted. That's why we use HSC. We can conserve the bandwidth, which we probably pay for. So be careful when you use encryption from your. Oh yeah, that's the comparison to this. Be careful when you take the VPN from your cloud service provider and you pay for the bandwidth. Maybe part of this bandwidth is consumed by your VPN. Okay. Another any questions? Let me check. Ladies and gentlemen, do you have? I'm checking. Nothing in the chat. Okay. Okay. No questions so far. So good. Another example of demo I'd like to share with you. This is based on the another test we did for. It was part of the POC. We did it for one customer where where the customers want to connect its on-prem HSE infrastructure based on the CN6010 and the virtual encryptor in AWS, similar to what you saw on the previous slides. Let me quickly describe what were the main goals. The main goal is to build a secure connection between the area called secure client and the secure subnet in AWS. The customer requirement was do not use any AWS VPN, any secure connection provided by the cloud service provider. Okay. Another requirement was to maintain the throughput. Okay, cool, we can do this. And encrypt all the IP traffic coming from to the secure client. As a test environment, we deployed one web server listening to port 80 with our encryption, to show the customer that without HSC in place, a network is visible to cloud, for example, any person in between. With HSC, no way. Okay. More or less, this is how the test environment, POC environment look like. So we have this secure subnet, and on-prem there was secure client located in one network segment, customer network segment. Prerequisites, of course, we have to obtain the CV1000 image and convert it to AWS machine image, because only AWS machine image can be deployed as the running server or running system. Also, we have to obtain the accompanying CM7 software. CM7 is our management application to manage HSE. Yeah, configuring hardware appliance on the on-prem, it's rather straightforward. We have to activate it, of course, set up date time, that's obvious. And the important part at the beginning, when we start the deployment, is to configure bypass all. Bypass all means run any traffic through me, no encryption, do not look at anything. Why is it important? Because if we start deploying quite complex infrastructure and immediately start to encrypting, it will be really hard to troubleshoot this. So my recommendation, first of all, run without any encryption, bypass all. When you are sure that traffic goes through your on-prem to the cloud, then configure the encryption. Okay, so next step, we run this environment on customer side, so secure client, and we want to build this here marked in red secure channel to this secure subnet run in AWS. We have to know what is our outgoing IP address, because we have to configure IP rules. I will show you later on how it looks like. And yeah, of course, network interface in our HSC, it's interface which encrypts the data. Local is the interface where we see unencrypted data. Yeah, so That's why we have this direct connection. And of course, management. In this case, we use it as a one network. However, it depends on the customer requirements. It could be the separate management, and could be separate network at all. Okay. How to deploy CV1000 in AWS? I don't want to bother you with all these details. However, if you are interested, we have the detailed guide how to do that. And we have to do nearly the same as we do for hardware appliance. We have to define 3 networks: management, local, and network. And properly configure subnets and, very important, routing tables. AWS, with defining the network in AWS, you can also apply the security group policies. This is very important. This is saying it's simple. This is the firewall. Which traffic is allowed between which networks? And one important thing is, you see my security group. We allow the traffic to the system. We allow the traffic to manage the devices. Okay. Your security group can be more sophisticated and different for incoming and outgoing traffic, no problem. But one thing is important: you have to enable protocol number 99. Protocol number 99, don't please confuse it with the TCP port. Protocol 99 means custom encryption. The firewall in AWS must allow this datagrams which contains the custom encryption through. So one important remark, and of course, we have to properly assign networks to the network interfaces of CVT. Again, I don't want to bother you with details. Another important settings is just to disallow checking the source destination between network interface, because in normal circumstances, because we manipulate the packets, IP packets, we have to disable this checking on the HSE networks. Only there, no other. This is not recommended, of course. And eventually we get this environment. Okay, so HSE deployed inside AWS, local unencrypted network connected to my secure subnet, management to management, doesn't matter, network assigned to elastic IP to be able to achieve to send packets to this network interface. Okay, and now we can start the routing tables is very important because in AWS you have to precisely define what is the flow of the traffic. That's important to know that for network and management we have to assign internet gateway. Yeah, as you saw on the picture, those two interfaces must be able to. Of course, for the production environment, only network is necessary for configuration management if you want to do this over the internet. Okay, so routing tables, and this is our final configuration. Yeah, we have 2 external IPs, one for management, one for accessing my secure subnet, and we will put sniffing here. We use simply switch, which has a mirroring port. So we mirror any traffic going out from network interface of HSE to the Wireshark. Okay, now all my traffic is working. Now we should configure the encryption, on your own terms. So there are a couple important steps. With our virtual encryptor, you can use only team mode, transport independent mode. Yes, because the traffic we see from on-prem to the cloud is only IP. There is no direct connection on the layer 2. So important setting is to set operational mode to team, set encryption policy. Yeah, both parties must talk to each other in the same language, and we have to assign a derivation. This is the most important part of this. Key is a encryption key, which can be generated by CM7. The management can be taken from one of the hardware appliance, depends, or delivered from the file. It's up to you. But this key must be uploaded to each encryptor, because this key is the source of all the key sequence used by encryptors to encrypt traffic between each other. Okay. And yes, as you can see, this is the final configuration here. By the way, this is the screenshot of the CM7, how this looks like. CN6010, this is the physical appliance. CV1000 IWS is the virtual one. As you can see, the operational mode here is team, KDF, key distribution file, counter, and IS256 in CGM mode. The same is here, and the only difference is that group key sender ID must be different on each HSC exchanging the packets. That's very important, because based on this sender ID, HSC knows what is the sequence of the encryption key for the particular encryptor. Of course, we can talk one-to-many, not like in my example, one-to-one. This is, of course, the simple use case. Okay, so this is my working environment. And at the first test, we simply change the encryptor's global mode to bypass all. No, don't encrypt. Yeah, which means don't encrypt. Do nothing with the packets. By the way, you can see here the IP rules I mentioned in this. If we go back, my on-prem encryptor will encrypt any traffic going to this destination IP here. Let's look back. If you remember, 13.50.144.130 is IP of my secure subnet. Yeah, so network interface in my virtual appliance. So if that guy sees that IP packets coming from here in here is towards this IP, will encrypt datagram. Okay, and this datagram will be delivered by all the network staff here to this gentleman. And this gentleman, HSC, seeing that packets this source is from my outgoing IP, will decrypt this packet. That's why we put very little overhead on the IP datagrams, and that's why we achieve this high performance. Okay, so first attempt is bypass all, and I can achieve my web server running on Apache with the browser. Cool. Okay. Now we will sniff the network here, and let me. Yeah, this is the movie of Wireshark. Sorry, the interface is in Polish, but yeah, my Wireshark is in Polish. But yeah, I think this is obvious for you how this traffic looks like. Oh, first of all, we see level 3 traffic. Yeah, which means, okay, I see the sequence. Let me speed up this a little bit. This is still nothing. Keep in mind that we work in the team mode. But, oh yeah, now, you see, we see what is the IP datagram. This IP datagram, for example, here is for HTTP request, GET. Yeah, so we can interpret these datagrams. And yeah, we see the traffic, everyone from my secure client to my secure subnet can see exactly the same. Okay, let's move on. Okay, now I simply enable encryption, encrypt all. This is the global mode for both. Yeah, you have to apply it to both. And that's it. That's all you have to do. No additional configuration, exchanging key or stuff like that. The encryptors know how to play with the packets coming from another encryptor. What was the AS256 key to use to encrypt datagrams? What will be the next key? And when I have to change the encryption key, because there is another setting saying that every 60 minutes change the encryption key. Yeah, so HSE know how to change the encryption key to the next one in the sequence. Okay, let's enable this encryption. Again, I can request my web server. Nothing changed. For application, it's absolutely transparent. As you can see, encrypt all is here. So let's look how the, oh yeah, maybe we should start it here. Okay, so drop the previous session, and now we will sniff the traffic when HSE encrypts the IP datagrams. It takes a while. You see, we have the filter. We only observe the traffic going to my AWS environment. Wait. Yeah. Oh, look. Now our Wireshark. Let me stop it. See only IP datagrams with no further. Oh yeah, we can look into the datagram and we see garbage. No patterns, nothing readable for human. And as you can see, the protocol identified in the IP datagram is 99. If you remember my previous slide, 99 means custom encryption. And this is, of course, we recognize that this is sent by Palo Alto based on the MAC address, based on the hardware address. Yeah, we know this, but the rest is absolutely encrypted by the HSE, okay? With minimum, absolutely minimum overhead on the IP datagrams. This is how HSE in team works, in team mode works. Oh yeah, we can, I think we can stop it. Ah, started from scratch. Oops. Yeah, more or less this is all regarding this demo. Let's, any questions? If you are not shy, you can just unmute yourself and ask. Okay, no questions. So let's move back to the presentation and summarize what we saw. Okay. Our HSE, it's can provide the quantum resistant algorithms. It's a quantum safe solutions. Yeah, it consists of couple solutions we have already in HSE. First of all, as I said, this is crypto agility approach. So we can update our HSE without replacing hardware in order to provide post-quantum algorithms or accelerate it in the hardware just to keep this throughput for the customer. That's the one. Second one, our hardware platform is equipped with quantum random generator. Of course, this is not against the quantum computer, rather it increased the security because we delivered really random number generator, random number, which is crucial for generating really unpredictable encryption keys. Nowadays, we use deterministic random number generator, which is pretty random, but we can't guarantee it. With quantum random number generator, for example, we have cooperation with our technology partner IDQ. The chip, which uses the phenomenon of quantum physics, for sure, this is proved by physics, quantum physics, for sure provides the random number generators. Another solutions we support is quantum key distributions. This is something which our HSC supports quantum key distributions. We do not provide the quantum key distributions solutions. There are another third-party vendors on the market, but we consume the quantum key distribution. What is the quantum key distribution? If you remember the encryption basics, with symmetric encryption, which is not affected by the quantum computer, the problem with symmetric encryption is how to deliver this key in the secure way to Bob and Alice, to both parties exchanging the data. Okay, how to do it in the secure way through the unsecure environment. Quantum key distributions does not provide that channel. It provides the channel where we can deliver the symmetric key between Bob and Alice in the way we know that someone is eavesdropping the channel. Okay, cool. This is nice. At least I know that somebody is looking at my symmetric key I exchange with that third party. Okay, this is nice. Nowadays, the solutions on the market are based on the photonic channels, and this is here. Of course, when we distribute the key, it must be consumed by the endpoint which is able to encrypt something, for example, network traffic, based on this distributed key. And the last is the quantum resistant algorithms. Yeah, as I said, NIST recently published the quantum resistant algorithms standard, and soon it will be in our regular firmware. However, nowadays, today, with firmware 5.2.1, as I remember, we have this pre-standardized algorithm, and they work fine. They work fine because, as I said, our HSC talk to our HSC, so there is no problem with the compatibility. Of course, both or many HSC must have the same configuration and the same firmware. I think it's obvious. Okay, it's almost 10:48, so we should finish our webinar today. Key takeaways for you. High-speed encryptors stands for high-speed encryption, or encryptors, as I said. It's a solution. It's available as a physical device with high tamper-proof in many factors, including on your own platform. If you want, we can also verify if your x86-based platform is able to run HSC operating system. Also available as a virtual. You saw this during the demonstration. Some customers where the workloads are located in the cloud. By the way, virtual HSC can be run in Azure environment as well, and in KVM environment, so in hypervisor as well. HSC protects the data in motion across networks from 100 megabits to 100 gigabits. We talk about the effective encryption throughput, not the speed of interface, physical interface. Yeah, we support many, including the fiber optics, many transceivers as well. Encryption can be applied at layer 2, which is easy peasy, obvious for us. Could be line mode, it could be VLAN mode, even the MAC mode. The recent solutions can also apply encryption on level 3 and level 4 encryption layer, network layer. Okay, all these solutions provide the maximum security without performance degradation, which means, for example, 0 jitter and latency below 10 microseconds. 10 microseconds is for the lowest model. Of course, this is applicable only to hardware. Yeah, in the virtual appliance, we can't guarantee 0 or latency. That's I guess obvious for you. But the highest model, this 9000 series, provide latency below 2 microseconds. Microseconds, not milliseconds. Okay. Of course, certifications, global recognized certification, which prove that our solution is trustful. We have quantum safe solution on board already. And thanks to the crypto agile, which is another outstanding feature of HSE, we can do the field updates without replacing the hardware itself to follow the recent security advices from certification bodies. We can accelerate the algorithms which are the most demanding from the market, for example. And of course, post-quantum crypto support is part of our crypto agility approach. Okay. Thank you very much. This is more or less all from my side. If you would like to test HSE, get the free 90 days trial hardware, of course, hardware we can evolve for you. For the virtual appliance, virtual HSE, you can request based on this URL or QR code, you can request 90 days trial.